So in this video, we're going to cover the basic concepts of network modeling within ESM. We'll review the various resource types ranging from customers to networks to asset ranges, and zones. What is the network model? Well, the network model consists of customer, network, zones, asset ranges, and assets that ultimately represent the individual nodes that make up the network. They could be your subnets within your topology of your network, such as like your DMZ. It could be, for example, your PCI enclave. Ultimately, the network model is used to identify the traffic of where the attacker or the target exists within the topology in order to better represent the information so that as analysts look at the information of the event stream, they can make better determination of what they should do with the event that is actually occurring. So now let's look at each of these elements in a little bit more detail in the next slide. So carrying over from the previous slide, you can see that there are a number of elements within the resource types that are part of the network model. Customers are used to describe various businesses and or internal cost centers for tracking events and load. Networks are used to differentiate two private address spaces where there could be, for example, IP overlap. Zones get into the actual portions of contiguous IPs for within the networks. Asset ranges are used to represent a group of nodes, nodes being the individual assets that exist within the environment, such as a server, a desktop, etc. So first we'll cover the customer resource type. It's ultimately used to tag the event to signify, for example, the owner, normally used by MSSPs in order to differentiate customer and keep traffic separated so that access rights can be used to segment the information that's being presented to users or within reports that they're being delivered to the customers. That value can either be a fixed string or can actually be a velocity template variable, as we'll see later when we walk through the console, taking a look at each of these examples. So networks are an ArcSight resource that are used to differentiate between zones where IP ranges may overlap. This may occur, for example, through mergers and acquisitions, where the same IP ranges are used between the various companies before they come together. This allows you to keep them separate. ESM comes with two networks already configured out of the box, local and global, where local is the private IP spaces and global is everything else. Ultimately, a network can only belong to one customer. Again, that part is important because as events are tied back to an individual customer, you have that one-to-one relationship. So zones are part of the network model that represent or are identified by contiguous IP range. They represent a functional group. As you can see on the right-hand side as well, here that it could be, for example, the wireless LAN, VPN segment, the DMZ, your databases. And ultimately, each asset or address range has to have a zone associated. Now, to help you, there are some defaults that do exist. For example, some zones might be for the internal, would be your 172, your 192, or your 10.IP ranges, or your global, which would exist by default out of the box in order to ensure that events as they come through do match a zone. And again, a zone can only belong to one specific network. Again, we'll get to see that in more detail when we do the walkthrough, the console, looking at the network modeling resources. So one of the key settings I wanted to touch on briefly here is the difference between static and dynamic zones. Static being assets that would be, for example, having fixed IP addresses. Dynamic zones might be something like a VPN pool or a zone where there are desktops using DHCP. The reason it's important is that when these are misidentified, it can result in assets getting created, kind of like duplicate assets where the name is the same with the 1 or 2 or 3 appended to it on each iteration as it auto creates this, whether it be from the import or auto asset creation process. So like the network resource type, the asset range is a group of assets that you don't necessarily want to individually track. For example, like a group of desktops or PCs that could be coming in or out of the network. It wouldn't be necessarily consistent. So instead of creating them as individual assets, you define it as an asset range. So as events flow into ESM, they are associated to the asset range dynamically by membership. So in the example below, you can kind of see that the range has been defined as a range from the .10 all the way through .20. So as any asset appears within that, it is dynamically associated to the asset range, and as such, it naturally inherits any other attributes associated to that asset range, such as your network, your customer, or other elements from the asset model. One element to note is that when developing content and using the asset attributes to look up any part of an evaluation, even though the asset specifically may not be defined, as long as it falls within an asset range, it will pick up attributes, for example, that are associated to the asset range, such as the asset model or any other inherited elements. So the last resource type that we have to talk about in a network model is assets. Assets are the individual nodes that are uniquely identified. They contain the IP address, the MAC address, the host name, and other attributes associated to the individual server or individual desktop that is specifically named, using those elements to uniquely identify it. So in this video, we're not necessarily going to go through all the various ways to populate the network model. I wanted to just kind of point out that the individual method, which is going into the console and accessing the individual resource and inputting this information, leveraging the smart connector based on vulnerability scanners that are pulling data in, or from an asset import connector. We'll kind of touch where you kind of look at where that may be, as well as there's some other assisted utilities that are out there, such as Resource Gen, which is field developed, that can make it easy to do massive imports of asset information from an export from like a CMDB or some other data source that contains all the asset information. So next up, let's give a quick look over into the console and review a number of the key elements that we kind of covered during this presentation. So now that we're actually in the console, let's look at the resources that we had recovered throughout this video. So when we look at the resource tree in navigation, the two areas that we're going to be concerned with are the customer's resource type and the assets. So first we'll start at customers, and as you can see, I have some customers that are defined here. And again, if we look at the entry for the customer, you can see here that there's some basic information. There are networks that are associated to this customer, and as such, that can be done simply by doing an add. And if we wanted to choose one of the other ones like local, we would just click OK, and it would be added to this list right here. So it's pretty straightforward for doing customers. Next, we'll move into the asset side. So when we look at assets, there are a number of tabs here. Now, some of these belong to the asset model, which we'll cover in a different presentation. Right now, we're just going to focus on the resource types that we covered during this presentation. So coming back down through the same order that we kind of covered this, and we will go into networks next. So as you can see, within networks, there were mentioned that there were some defaults. So here's local and here's global that were mentioned. You can see that there's no customer associated, but there's only the dialog to enter one value. So if we ultimately click in here and choose one, we, for example, choose ArcNet and click OK. That's the only one that's available. If we go and have to choose another one, for example, that value, as you can see, it ultimately does not have the option to put multiple customers, so that 1-to-1 ratio still exists. Likewise, any zones that are associated could be inherited and shown here, because again, that a zone is affiliated to your customer, to your network zone. So let's move down into the zones and look there real quick. So zones, as we mentioned, are the groupings of assets. So we'll go ahead and look at this one real quick. As you can see, it's a contiguous IP range. It goes from the .1 to the 254. Again, the network is here. It's associated to the ArcNet that we have put in here. If there were specific assets, we can allocate those assets here. So you can see that there are 3 explicitly associated to this zone. And as we move through this down into the assets, again, you can see that the assets themselves, for example, contain the specific information, the IP address, MAC address, host name, again, inheriting the zone, which one it belongs to, whether or not the asset is static or dynamic. And we can see if there's alternate interfaces to this individual node, we can associate if it has like 1, 2, 3, 4 interfaces here, so that if we do see traffic coming in on one of the alternate interfaces, it gets associated to that actual endpoint node that we're referring to when we define the attributes accordingly for IP address, MAC address, and name. In order to do an asset range, it's not much different than creating an asset. So we just say a new asset, and when we do that, we can actually define a new asset range as well. For example, asset range, we can choose the dialog. The difference is that there's a start and end address in the asset range versus an asset only actually has an individual identification. So therefore, it would only have the individual IP address, unless, of course, there are alternate interfaces, and we would just go to that tab and add that dialog. As we move through this, one of the other elements I wanted to point out was the network model. From here, this is one of the dialogues that we kind of mentioned that I said I would point out. From here, you can quickly load asset and zone information using a CSV. It does some mapping. It's wizard driven. It's very easy to use. In order to populate some information, it can kind of get you up and running fairly quickly, as well as some of those other automated import methods that we kind of mentioned earlier at the presentation. So one of the other things I want to kind of go over and show you was how some of this information, when it's put together, is presented to the analysts as they're kind of looking at the console and working and triaging events as they flow into the environment, and work on those, to determine whether or not there's something that, they should be actioning. So we see that this, for example, this event right here, proxy, we see a miss. It's on an internal attacker address. We can see the zone name is mapped to the RFC 1918, which is that IP range. In general, I would recommend naming zones by the full name with the IP start and stops. It helps the analysts understand if they're traversing various subnets, for example, where there could be IP ranges. Likely there would be a firewall in between it. An analyst may not know if there's anything in between that if you don't necessarily represent it. If not, at least have some level of detail. For example, New York versus HQ versus San Jose, so that the analyst actually has some context added into what they're seeing within their console, whether it be for the target, if you have internal to internal based traffic, or one data center to another, or if you're seeing inbound attacks from the outside, understanding what segment of the network they're actually witnessing this to. There's only so much an analyst is going to be able to ingest and understand the full topology. And if there are things that are dynamically changing, let's say, for example, subnets within a virtual environment, feeding this at the network model off of, like a UCMDB would, of course, address, any of those dynamics automatically, so that the analyst can stay up to date with what's going on. So the last area I wanted to kind of go through is the connectors and the network model, and how some of the settings are for here. What we are able to do, you can see in the connector, we look at under the default tab, there's a section called network. And within network, there's some areas of interest right along here. So customer URI, the source zone URI, and such. What it allows us to do is define these in very specific values for tagging the connector specifically. This is in particular something that may come across when you have a topology, when you're dealing with an MSSP and you have some shared environments, shared connectors, and that the customer IP address is very specific. There may be multiples, but the connector is purposed for a specific customer. So you may manually set that so that when the mapping occurs for the network model, it inherits these values here. One of the other areas I wanted to point out was this right here is a velocity macro set, or velocity template variable set. We'll kind of show it here so you can see it. So you can see there's an if the device host name ends with, bear with me, the HK Financial, it sets the value to ArcNet customers ArcNet ArcNet all customers HK Financial, and then there's an else in here. If I can get it to show you cleanly, there's an else condition that basically, if it doesn't meet the condition for the first part, it has a default value that of course would associate. So the else would set it to just the ArcNet. So it's one way you can dynamically set the customer URI that we mentioned earlier in the event that you need to pull it off of some other pieces of information based on a dynamic layout such as this. Another area to note is zone population. You can even turn off the zoning. Sometimes you may do that when you are setting the customer or some of the other elements of the network model in a map file, for example, in place of doing it at the connector level in this way. As well as rezone override might be a way that you deal with some inconsistencies that you may find or uncover when you're doing forwarding through a logger before it gets to ESM. That way the information that's being put and displayed into the active channel when we were looking at it doesn't get overwritten by something that, say, for example, the logger may be putting in. One of the other things to note, lastly, I wanted to kind of cover is if you don't have a customer URI and you are seeing a hit or miss on some of the network mappings, one of the things we've witnessed in the past is when the customer URI is actually defined in a connector, we don't see the misses occurring. This is in various versions prior. Mileage may vary, but definitely once the URI is set, we haven't witnessed that in any from a field standpoint where there could be an inconsistency where something might be slipping through. So it's one of the other areas to note when you're deploying your connectors and associating your network modeling. Let's get back to the recap and conclude our presentation. So in this video, we've kind of gone through some of the key elements around the network modeling, the core areas that address some of the multi-tenancy, MSSP configurations, some of the elements if we were going to do a chargeback, such as defining the customer, naming conventions around zones and asset ranges in order to provide context to the analyst, as well as some of the ways that you can populate the information. One of the other key things to note is that if you don't undertake developing a custom network model, even though ESM has a requirement that there is a network model in place, there are defaults in place regardless of whether or not you undertake these activities, ensuring at least the basic level of context for analysts as they work through the active channels and the information that are being presented based on that information. Thank you, and this concludes the video on the basics of network modeling.